Good day, everyone! Welcome to another session of fruitful learning and understanding here in our FB Live. I am Miss Alma G. Di Maano from Fernando Urbes Integrated National High School, and I will be your teacher for today in Practical Research 2. Research indeed is a tasking endeavor. However, its importance in almost all fields and walks of life overpowers the tedious procedure that one has to undertake in order to complete it. Acquiring skills in research can spell a very big difference in whatever career you decide to pursue in the next chapters of your life. In the previous lessons, you have learned the step-by-step procedures that one has to follow in order to complete and lay down a research paper. And today, we are going to focus on the appropriate instruments to collect and gather data and how to present them in tabular and graphical forms. So, without further ado, let's get this ball rolling. Data collection is a methodical process of gathering and analyzing specific information to prefer solutions to relevant questions and evaluate its results. It focuses on finding everything that there is to a particular subject matter. Quantitative research methods are means of collecting numerical data through the use of standardized techniques, then applying statistical methods to derive insights from it. Researchers usually use this method to get objective and conclusive answers. There are 4 types of research tools in this particular area. They are the questionnaire, observation, interview, and records. Let's get to know them one by one and understand their advantages and limitations. Question: if your objective is to find out the characteristics that students of Fernando Urbes Integrated National High School look for in an officer of the Supreme Student Government or the SSG, what data collection method will be best to use so that you can cover as many students as possible? Will it be A, an interview, B, questionnaires, or C, observation? You have 5 seconds to type in your answers on our chat box below. And if your answer is B or questionnaire, then you are correct. Questionnaire. This is the most common type to collect quantitative data. A questionnaire, also called a survey, is a series of questions usually written on paper or, in our situation now with this pandemic, a digital form. The questions are designed to gather data that would help researchers answer the research questions. For example, if you are trying to investigate the study habits of the senior high school students of FAB-INHS, and one of your research questions is, describe the length of time spent by the respondents in studying every day, you may opt to include in your questionnaire this question. If, in the same study, you have a research question, what challenges or problems do the respondents encounter in studying? Then, you can include this question in your questionnaire. Both a close-ended question and an open-ended one are acceptable in a research questionnaire. An example of a closed question is the first one that we had given a while ago. And the second we discussed is an example of an open-ended one. The advantages of using a questionnaire as a data gathering tool are the following. 1. Questionnaires are often less time-consuming than interviews or other in-person quantitative research methods. Second, they're common, fairly simple way to collect data. Third, they can be cost-effective for gathering data from a large sample. However, it also has its limitations. 1. Responses may lack depth and provide limited information. 2. Respondents may lose interest or just quit if the questionnaire is long. And lastly, respondents may not understand all the questions, which would lead to inaccurate responses. Now, here is another question. If you have a limited number of respondents and you wanted in-depth information about your topic, what method of data collection is more appropriate to be used? Will it be A. An interview, B. Observation, or C. Records? I know you have the answer on your head now, so go on and type in your answers on our chat box below. And the correct answer is, of course, letter A, or interview. I hope you got it right. An interview for quantitative research involves verbal communication between the participant and the researcher. The interview can be conducted face-to-face, over the phone, or, as dictated by our current condition, it can also be done through virtual platforms. It can be structured or unstructured. In a structured interview, the researcher asks a fixed set of questions to every participant. The questions and their order are predetermined by the researcher. The interview follows a formal pattern. Structured interviews are more cost-efficient and can be less time-consuming. However, its preparation requires careful analysis of your objectives. You have to see to it that the designed interview questions can cover and would elicit adequate data from your respondents. For example, if you want to find out the career preferences of the grade 12 UM students of 5 INHS, and you have the following research questions. 1. What course do the respondents prefer when they enroll in college? 2. How would the respondents describe their ideal job in the future? 3. Who or what influenced the respondents in their chosen career? 4. What challenges do the respondents foresee in pursuing their chosen course? And 5. What action plan can be instituted to fill the gap found in the study? In this case, you may design your structured interview questions like this. 1. What course do you prefer to enroll in college? 2. How can you describe your preferred career or job in the future? Do you think your chosen course can lead you to this ideal job of yours? If yes, how? And if not, why? 3. Who or what influenced you in this decision? 4. What challenges do you foresee in pursuing this course? And 5. How do you think the school can help you be more prepared in pursuing your preferred course? On the other hand, in an unstructured interview, the researcher thinks of his or her question as the interview proceeds. This type of interview is conversational in nature and can last for a few hours. This type of interview allows the researcher to be flexible and ask questions depending on the participants' responses. This quantitative research method can provide more in-depth information since it allows the researchers to delve deeper into a particular respondent's response. Interviews have the following advantages. 1. it can provide more in-depth information. 2, it is more flexible than a questionnaire, since interviews can adapt their questions to each participant or ask follow-up questions. And lastly, it can clarify participants' questions, which will help them get clearer and more accurate data. On the other hand, interviews also have limitations, like interviewing one person at a time can be time-consuming. And of course, travel, interviewer budget, and other expenses can make interviews an expensive data collection tool. Here's another question for you, my witty students. If your investigation involves behavior, such as how interesting a subject is to the students, or who among your classmates has a habit of doing their homework in school, what data collection tool can help you obtain unbiased data? Is it A, an interview, B, records, or C, observation? What are you waiting for? Go ahead and type in your answers because your 5 seconds starts now. Time's up? That is correct. The correct answer is letter C, observation. Observation is defined as a systematic way to collect data by observing people in natural situations or settings. Though it is mostly used for qualitative data collection, observation can also be used to collect quantitative data. Observation can be simple or behavioral. Simple observations are usually numerical, like how many students passes by your corridor while classes is going on, or how many students are asleep during a class. Behavioral observation, on the other hand, observes and interprets people's behavior, like how many cars are driving dangerously, or how engaging a lecturer is. Simple observations can be a good way to collect numerical data. This can be done by predefining clear numerical variables that can be collected during observation. For example, what time students arrive in school. This data can be collected by observing students over a period of time and recording when each student arrive in school. For the advantages of utilizing observations, the following can be said. Observation is often an inexpensive way to collect data. Since researchers are recording the data themselves, rather than participants reporting the data, most of the collected data will generally be used. Data collection can be stopped and started by the researcher at any given time, making it a flexible data collection tool. As of its limitations, researchers need to be extensively trained to undertake observation and record data correctly. Sometimes, an environment or the research may bias the data, like when participants know they are being observed. And lastly, if the situation to be observed sometimes doesn't happen, researchers may waste a lot of time during data collection. Question: suppose you are doing an analysis of the 3-year NAT results of the grade 11 students of FAB INHS. What data collection tool is best to be used? A, an interview, B, observation, or C, records? Now, move those fingers and key in your answers. If you typed C for records, then congratulations, you are correct. Since quantitative research depends on numerical data, records, also known as external data, can provide critical information to answer your research questions. Records are numbers and statistics that the institution uses to track activities like attendance in a school or the number of patients admitted in a hospital. For instance, if you want to correlate the grade 12 ABM students' academic performance in the core subjects vis-a-vis their involvement in co-curricular activities, the teacher's class records in 21st century literature, intro to philosophy, applied economics, contemporary arts, and other offered core subjects can be a very useful source of data. The advantages of using records are: records often include comprehensive data captured over a period of time. Data collection time is also very minimal since the data has already been collected and recorded by someone else. For its limitations, records often only provide numerical data, not the reason or the cause behind those data. Cleaning badly structured or formatted records can take a long time. And lastly, if a record is incomplete or inaccurate, there is usually no way to fix it. And there you have it, my dearest class, the 4 mostly used tools in data collection for quantitative research. It is important to decide the tools for data collection because research is carried out in different ways and for different purposes. The objective behind data collection is to capture quality evidence that allow analysis to lead to the formulation of convincing and credible answers to the questions that have been posed. Can you join me in enumerating them? Questionnaire, interview, observation, and records. That was great! And now, we are ready to present our data in tabular or graphical forms. To be able to create and present an organized picture of information from a research report, it is important to use certain techniques to communicate findings and interpretations of the research studies into visual form. The common techniques being used to display results are tabular and graphical forms. When we talk about tabular form, we of course refer to tables. Tables present clear and organized data. A table must be clear and simple, but complete. A good table will include the following parts: the table number and the title, which are placed above the table. The title is usually written right after the table number. We will also have the caption subhead. This refers to the columns and the rows. The body, which contains all the data under each subhead. And the textual analysis, which is the interpretation in textual form that is given to the table. Now, do you think you could help me put these labels on the appropriate parts of the table? Be my guest! Well done, my dearest students! Meanwhile, a graph or a chart portrays the visual presentation of data using symbols like lines, dots, bars, or slices. It depicts the trend of a certain set of measurements or show comparison between 2 or more sets of data or quantities. The line graph, the bar graph, and the pie graph are just some of the most commonly used graphs in presenting data. Now let's see if you can recognize these kinds of graphs. This is an example of what kind of graph? I'll be waiting for your answers on our chat box. You are correct. This is an example of a line graph. And how about this one? Can you recognize it? Again on our chat box. And the correct answer is, of course, there you have it, class. The 4 most commonly used tools in gathering data in quantitative research and how to present them in tabular or graphical forms. See you next time! Welcome back, my dearest students. I'm so glad to be with you once again in this another session of FB Live in Practical Research 2. For this episode, we are going to focus on using statistical techniques to analyze data with emphasis on the study of differences and relationships of bivariate. We are also going to tackle drawing conclusions and formulating recommendations. Data in statistics is sometimes classified according to how many variables are there in a given study. For example, gender might be one variable and grade level may still be another variable to be considered. Depending on the number of variables being looked at, the data may be univariate or it might also be bivariate. If, for example, you are going to study the pre-test results of the grade 12 ABM students in 21st century literature, then you are looking at one variable. Can you guess what kind of data are we dealing with here? Exactly. Since we have only one data to analyze, you have a univariate data. However, if you would like to analyze the achievement of the same set of students in the same subject by comparing their pre-test and post-test results, then you will be using 2 kinds of variables. Wanna guess again? Right! Their pre-test and post-test data are 2 different sets of data. Thus, you now have a bivariate data. Bivariate analysis simply means the analysis of bivariate data. It is one of the simplest forms of statistical analysis used to find out if there is a relationship between 2 sets of values. The most common types of bivariate analysis are scatter plot, regression analysis, and correlation coefficient. Let's take a look at them one by one to understand when to use them. A scatter plot, aka a scatter chart or a scatter graph, uses dots to represent values for 2 different numerical variables. The position of each dot on the horizontal and the vertical axis indicates values for an individual data point. Scatter plots are used to observe relationships or correlation between variables. For example, if we are comparing the pre-test and the post-test results of your respondents and you have the following data, then your scatter chart will be like this. The patterns or the correlations found within a scatter plot will have a few different features: positive or negative, linear or non-linear, or a strong or weak relationship. Positive or negative. A positive correlation will point up, while a negative one will point down. If the data points in a line from the low x and y values to the high x and y values, the data points are positively correlated, like in the given example. On the other hand, if the graph starts off with a high y values and continues to the low y values, then the graphs are negatively correlated. Correlations can also be linear or non-linear. A linear correlation forms a straight line in its data points, while a non-linear one might have a curve or other form within its data points, like these examples. The last feature, strong or weak. A strong correlation will have data points close together, while a weak one will have the data points farther apart from one another, like this. In the case of 5 highly competitive students, the researcher would like to know if there is a relationship between the students' abilities in English and mathematics. A 20-item test was given to them and the following scores were obtained. Do you think you can plot this data and create your own scatter plot? I will give you 30 seconds to do this. Okay, time's up. Let us compare now your work with the correct one. Nice try, everyone! Now that scatter plot is thoroughly explained, let's jump on to the other form of analysis for bivariate, the regression analysis. Regression analysis is a set of statistical tools used for the estimation of relationships between a dependent variable and an independent variable. It can be utilized to assess the strength of the relationships between these variables and for modeling the future relationship between them. Regression analysis includes several variations such as linear, multiple linear, and non-linear. The most common models are simple linear and multiple linear. Nonlinear regressions are commonly used for more complicated datasets. Simple linear regression is a model that assesses the relationship between dependent variable and an independent variable. The simple linear model is expressed using the following equation. Meanwhile, a multiple linear regression analysis is essentially similar to the simple linear model, with the exception that multiple independent variables are used in this kind of model. The mathematical representation of multiple linear regression is like this. Regression is used for forecasting, time series modeling, and finding the causal effect relationship between the variables. For example, relationships between rash driving and the number of road accidents of a particular driver, or students' tardiness and their academic standing are best studied through regression. Question: which of the following research topics can be best conducted using regression analysis? A. Why students procrastinate. B. The number of hours devoted to study and their academic standing. Or letter C. Characterizing the lived experience of the senior high school students in distance learning. Key in your answers and I will be waiting. To get the correct answer, you should have keyed in letter B, or the number of hours devoted to study and their academic standing. Moving on to the last type of analysis for bivariate data, we have the correlation coefficient. To obtain the quantitative value of the extent or the strength of the relationship between two sets of items, it is necessary to calculate the correlation coefficient. So essentially, the correlation coefficient are used to measure how strong a relationship is between two variables. The values of the coefficient correlation ranges between a positive 1 to a negative 1. A positive 1 indicates a strong positive relationship. Negative 1 indicates a strong negative relationship. A result of 0 indicates no relationship at all. The absolute value of the correlation coefficient gives us the relationship strength. The larger the number, the stronger the relationship. For example, a computed coefficient of positive 0.75 has a stronger relationship than a computed positive 0.65. Usually in statistics, we measure 4 types of correlation: Pearson correlation, Kendall rank correlation, Spearman correlation, and the point biserial correlation. And to end up our discussion of these methods of data analysis for bivariate, let me pose this question for you. The computed coefficient correlation of a negative 0.25 suggests a positive relationship between the variables. True or false? Answer please. And the correct answer is false. Now that you are done with the analysis of the data you gathered and findings are laid down, you are now ready to draw your own conclusions and formulate your own recommendations. Conclusions represent inferences drawn from the findings of the study. The number of conclusions coincide with the number of specific findings. It should not contain any number or measurements. If there are tested hypotheses in your study, the rejection or the acceptance of this hypothesis are placed under conclusions. Since the conclusion is the final result, it should give the final impression and it should summarize the learnings from the study. It leaves the reader no doubt that you have answered the questions posed in your paper. It is a wrap-up of the entire project and its completeness. It is important to remember that your conclusion should specifically answer the questions you posited in your statement of the problem. Therefore, a wise way of doing your conclusion is to follow and answer every question in your research question. If, for example, the problem raised in a research study entitled Reading Difficulties of Grade 11 Students were problem number 1, what areas do the respondents encounter difficulties in reading? Problem 2, is the profile of the student respondents significantly related to their reading difficulties? Then, you can craft your conclusion like this. For conclusion number 1, the student respondents had problems in the following areas of English reading test: vocabulary, sentence construction, and reading comprehension. For conclusion number 2, the profile of the student respondents, such as gender and mental ability, are significantly related to the reading difficulties of the student respondents. Also, you may find the following guidelines helpful as you write your own research conclusions. paper does not end with writing our conclusions. Recommendations typically play a vital role in any research study. Formulating your recommendations is easy, provided that findings and conclusions have been fully explained and completed. Recommendations are based on the findings of the study. They should not be based on your own beliefs or biases. They should not be too broad to lose its relevance to the exact topic of your research study. But why is there a need to give recommendations after completing your investigation? First, for policy recommendations. An example would be, teachers should be encouraged to conduct research papers and collaborate with other teachers in the preparation of modules, guides, and other instructional materials. Second, for recommendations for future research direction. Example, more research on the effects of playing computer games must be conducted in the future. Third, for recommendations to some problems discovered in the research study. Example, hire more qualified teachers in the area of science and technology. Fourth, recommendations for improvement or a change. And lastly, they may also be recommendations for the continuance of good practices. A good recommendation usually manifests these characteristics. It should be relevant to the study. The recommendation must be based on the result of the study and not on some bias or assumption that the researcher has. Logical reason should be evident. It should be well thought of. The recommendations must be a result of careful analysis of the findings of the study. And of course, feasibility and attainability. Recommendations must be practical, workable, and achievable, something that can really be done. Let us now analyze these statements. Letter A, a further study of the topic looking into other factors why students fail must be conducted. Letter B, there is no significant relationship between the respondents' mathematical abilities and their gender. Which one is a good recommendation and which one is an appropriate conclusion? Letter A is a recommendation which suggests another direction for a new study, while letter B is a conclusion that gives the result of the test of the hypothesis. There you have it, my dearest students. You have reached the end of your research papers. I do hope that this FB Live, just like the others before this, contributed to your understanding and the development of your research skills. Till then,